All right, so I think this is probably the most valuable tool that you guys have in here, because what it does is it relates every single variable, and including moles, and puts it all into one equation. It's called the ideal gas law equation. So really it's the most important equation that you would have if we go on later on and do reactions, because reactions, what you can do is you can get some, you can figure out moles from pressure and some volumes, and calculate products that are made in moles and reactants needed in moles and those type of things. So really, really important in the process of doing these. So I'm going to lay out the four laws that we've already done. Well, I guess we've done 5, but really the 4 that is included in what we call the ideal gas law. And then we'll come up with the ideal gas law. I won't show you how R is found. I'll tell you about R, what that is. So when you take a look at Boyle's law, it's pressure times volume, right? And you guys did problems where you take P1 times V1 equals P2 times V2, correct? You guys don't have to write this down, okay? Because you have it written down somewhere already. So Gay-Lussac's law is P over T. So we can take pressure 1 over temperature 1 equals pressure 2 over temperature 2, keeping a couple other variables constant. This is Charles' law. So then we did Avogadro's law. So what we can do is we can take all of these 4 and plug them into one equation. And we're going to call this the ideal gas law equation. And I'll explain to you what it allows us to do that the other laws, even the combined gas law, doesn't allow us to do. Like on the lab, you guys are supposed to use the combined gas law to look at before and afterwards. This law tells you instantaneously what the pressure is. It tells you instantaneously what the volume is if you're given the other variables. It tells you instantaneously what the moles are of a sample. So this is like right now. I know the pressure. I can figure the pressure out, or volume, or temperature, or moles. I can do that at an instant. I don't have a before and after picture. Okay? So what we can do is plug this all into one equation. So we have 4 variables that we need to plug in. They are pressure, volume, temperature, and moles. So what we'll do is we're going to set them equal to what we call a constant. And that constant is going to be indicated with an R. So we're going to have those all on one side of the equation. And then that equation, kind of like these are equal to K, this is going to be equal to a constant too, but we're going to label as an R because this is how you label the ideal gas law constant. Okay. So you tell me what should be on the other side. What should be on top or multiplying on the other side, according to the setups here. P should be on top. What else should be? V. Very good. Okay, is that it? Is that everything on top? Okay, so then we divide it by T and N, right? Because that matches up over here, what they are. So basically, we're just taking all of these, substituting them all together to get a constant R. Okay, now this is a step I'm not going to show you that we did in the other class, but volume always has to be in liters when you do this law. Okay, you can't have it in milliliters, microliters. It has to be units of liters. So if you have, like in our lab, you guys remember on the lab, it was milliliters, and I had you do what? Convert it to liters, so that you could have it in that. So that's what we need to do. The temperature is going to have to be in what?
Kelvin.
Kelvin. Of course, N represents moles. Okay, and we know that's the unit. So then we get to this pressure, and this is the one that creates problems. Because volume can only be liters, temperature can only be Kelvin, and moles can only be MOL, moles. But pressure, we can have 3 different pressures. We probably have more than that even. But the book kind of, a lot of books and problems are associated with 3 different pressures. So what's our different pressures? Atmospheres, millimeters of mercury, and a lot of times this is called torr. So if you get a problem, I don't think this book does it much, but instead of millimeters of mercury, they say torr. So like 760 torr is standard pressure. And then kPa, right? All right. How do you, if I put pressure in here, I got 3 different values I can put in for pressure. That's going to change the R value each and every time you do it. So, do we have to convert all to one type? You could, but I'm going to allow you the opportunity to not have to do that each and every time. So I'm going to give you the 3 R values for if you use pressure in those 3 different units. Okay? So I'm going to give you these R values. You can write them down. So if we use atmospheres, the R value is going to equal, that you use, it's going to equal 0.0821. Now, you guys do not have to write any units down for these. But they do have 4 units, and they are temperature. They're Kelvin, liters, atmospheres, and moles. But we're not going to write them down. If we have millimeters of mercury, the constant's going to be 62.4. If we have kPa, which I don't think you'll see very often at all, but it'd be 8.31. The 2 most common ones that we're going to see in problems are these top 2. They're the most common ones. All right? So, you guys, the other classes, we figured those out. But that's just kind of like, you can plug in the numbers and you can figure them out yourself, but that's kind of what we did. So I give you these all on the test. So on the test at the top, you don't have to memorize this. You don't have to memorize this equation here. This is the ideal gas law equation, just arranged a little bit differently than what we had it on the previous page. Because on the previous page, we had it arranged R equals PV over Tn. And so the new arrangement kind of doesn't have anything dividing. Okay, so it makes it a little bit easier. So the new arrangement would be PV equals nRT. So that's what we're going to use for the next 2 problems. PV equals nRT. And these work the same exact way as the other ones we did. You list everything out, and you got to solve for what you got to try to find. Okay. The nice thing about this one, I can solve for moles now at an instant, and that's probably the most important one to solve for. You'll find out later on. Okay. All right. So we're gonna look at our first problem. You guys see that? Okay. Now what I'd like you to do is down the side, just put, you don't have to put ones now, you just got to put PV nRT. Go ahead and write in your values for all of those that you can see in the problem. So write everything that you have. Now the R, you're going to have to get from knowing the unit of pressure that you're given in the problem. So I wrote down those 3 R's for you so that you could look at those to kind of see which R value you're going to have to plug in. So again, this is called the ideal gas law. It looks at the relationship between pressure, volume, moles, and temperature all at once. And we know the constant. We can find that. And that's never going to change for that particular pressure that you're going to use. So the pressure is 0.95. Volume is okay, it's in liters, I'm fine with that. If it was in milliliters, I'd have to change it. The moles, I don't know. The R I can figure out. Atmospheres is what? 0.0821, right? Okay. And the temperature, oh, I don't want to, I'm going to cross through that. It's what? 294. I'm going to put 0.2. So some of you are saying, well, why do you put 0.2? Just go to 294. So, like, I know this is not something that you guys will probably think about much, but it's like 273.15 plus 21.0. So when you line it up, right, the 5 rounds up, and so it's 0.2490. See, we have to remember how we did that. To figure out how far to go, when you add and subtract, you use the least accurate, and that would be the 0.0. So, but most of you guys are going to use 294. You're going to get the right answer anyway. So, not going to affect your final answer. Okay, so you guys know how to arrange that, right? So we have PV equals nRT, and the arrangement to solve for N would be what? N equals PV divided by RT, correct? Divide both sides by RT, then it leaves N, isolates it. So we've got 0.95 atmospheres times 0.890 liters divided by 0.0821 divided by 294.2. And then that gives us our N value. Okay, so then the next one I'll have you do on your own. Give you a couple minutes to process it. You kind of set it up the same way. And it's 0.035. Is that what you guys got? Mm-hmm. Okay, so significant digits, I got 2. So I got 2 in my answer, 0.035. So we get back to significant digits. Some of you still are counting this 0 as significant. I noticed that in the lab. Some of you guys are limiting your answer to 1 digit. So some of you guys are just leaving this like 0.04. And that's 1 digit. And do you think you get a much different answer, 0.04 versus 0.035? Yeah, it's going to be a big difference. Okay? So that's why you got to pay attention, especially in lab and significant figures. Okay. So the next one, I'm going to have you do the same process. Go through and solve for the temperature. And then we'll see if you get the temperature right. Because it's just switching the symbols around to solve for the unknown. Now, guys, it says to solve for the temperature in degrees Celsius here. Now, that doesn't mean you plug in Celsius into your equation. You have to, when you get your answer, it's going to be in Kelvin, right? So then you have to do what to get it in Celsius? Subtract 273. Okay? So when you do this, every time you get an answer, temperature is going to be in Kelvin. So go ahead and solve for the temperature in Celsius. I'll give you a couple minutes to process that and see what you come up with. Some students that set these up because they don't want to show the PV and RT. They just want to take the numbers, rearrange them, and plug them in. And there's just a lot of mistakes you can make when you do all those steps at once. So it doesn't take too much of an effort to put them all in and rearrange your symbols, and you got your answer. But again, we have people that like to hurry up, and they want to put numbers in right away because they don't want to wait and do something that takes like 20 seconds to do to put in all their values. Okay, so got them all, got to find temperature. This also allows you to see what equation you need to use. If you're labeling all of these, you go, oh, that's the ideal gas law because it's got moles in it and pressure, so that's the one I need to use, PV equals nRT. So then T equals PV over NR. I do have students that switch that around. Like 1 out of 10, when they do the algebra, they they switch it around. They'll have NR over PV. Okay, just real simple. You divide out from where you need to find, and this one we got to find T. So you guys have plugged the numbers in, right? So 821. I won't put units because I'm going a little quicker. 4.04 divided by n. See, I can go over here and get that. 127 and 62.4. So and that's another thing students will do. They'll pick the wrong R, and I can understand that from time to time that you can do that. And you got an answer out that is originally 419. Is that right, Kelvin? And then you subtract to get 146, right? Okay. All right. So do all that work. Got your Kelvin. You know, I wouldn't take hardly anything off if you didn't recognize you needed to have it in Celsius. You know, like if this was worth 4 points, maybe a half a point, maybe not even a half a point. I don't know. Okay, because I know that you're doing it right. You just kind of skip that step to go to Celsius. Questions you guys have? Now, this is where we stopped yesterday, but today it's not a big stretch because this won't take very long to discuss this second topic because we're still using the ideal gas law. Okay? So what I'd like you to do is write this problem down here. And got some extra information. And you're like, why do they give me this extra information? Well, most of the time, not all the time, most of the time, that extra information is important for you to use in your setup. So go ahead and write that down. It's asking for this thing called a molar mass. Molar mass. So that hasn't really come up yet. So we'll have to determine what the molar mass means and then use the ideal gas law in which to solve for it. So what you might do on the side, just put everything down that you think you might have to write down. So since this one has some things and doesn't really give us moles, it doesn't ask for moles. So what's up with that? It doesn't ask for moles. But we got volume and temperature. We don't have two different temperatures. We don't have combined gas law. So let's just kind of figure out what we need to do to get to our answer. So we do have the pressure, 740. We do have the volume, 0.6 liters. Moles, we don't have, so we're going to leave that blank. The R is be 62.4. Because of millimeters of mercury. And our temperature is 293. Whoa. Okay. So the question is, molar mass. What is it? Yes, very good. You told me my units. Grams per mole. Okay. So is there another number up there that we don't have included down here? We have grams of the substance right here. So we can go ahead and say, we can include a unit, it's a little m. and that would be 3.2 grams. Okay. So we have the grams here, right? So molar mass, capital M is a lot of times symbol as a molar mass. So capital M equals little m over what is mole symbol?
N.
Little n, right? Okay, so little m over little n is what you would do to find the molecular mass. So, what do you have? So solve for the little n and then we can solve our problem, right? So go ahead and solve for the little n. That's going to go down here. And our m, this one, is going to go up there, and then we get our molar mass. So on this one, it doesn't say to solve for moles, but you know, you got to go through and solve for moles. And then, after you guys do this, I'm going to show you a way that you can plug it all in one equation. And then I won't do it, I'll just show the work. And then you can look at it to see if that's something you want to do too. So I'm giving you two options of how you approach this problem and how you solve for it. So solve for the moles. Solve, and then you don't have to solve for mass, and then plug it in, and that gets you your molar mass. So just introduce this setup to solve for moles. Once you solve for moles, then you got to realize this grams here. The only problem using this method is this gram. Some students will want to take this and try to find moles of it, but they realize they're not going to be able to because they don't have what it is. So that probably should tell you right there that that's going to be used in which to set up your equation for grams per mole. So that's why you got the 130. So I'll put the assignment back. There we go. And some of those you guys have answers for, like 55 and 57 and 61, both C and D. You can double check your answers before you guys, as you go. So those are kind of nice to be able to do that from time to time. Some of them you can't, but most of these you can do that. Make sure that you have your R values written down somewhere where you can see them. I think all of you do. So why don't you take the rest of the time and work on that.
You write it down? You are a weak man.